All right. This is from third law part of the lab. And first just restate what Newton's third law of motion is. And then I'm going to have you identify some action-reaction forces. So I'm going to hang 200 grams, or about 200 grams. We're just going to call this an iron block. I put a hook on it. I'm just going to call the whole unit an iron block, though. We'll keep things simple. So if I hang this iron block on it, it reads 2 newtons of force pulling down. So what is the action force? What's doing the action, or what's the causing the force? The iron block is causing the force. Okay, so I have an iron block, that's the action force. And what's the reaction force? It's the hook from the spring scale. So I'm just going to call it the spring scale to keep it simple. The iron block is the action force. The reaction force is the spring scale. Remember, for every action there's an equal and opposite reaction. So we could say it this way. The iron block pulls down with a force of 2 newtons. The spring scale pulls back with a force of 2 newtons. Okay. They are equal and opposite. So the action force is the iron block, reaction force, spring scale. Now, what you're going to do now is, it says take 200 grams off the bottom scale. I did that. Connect the 2 spring scales so the bottom hooks are connected to each other. And we're going to pull them in opposite directions. And you're going to see that no matter which scale I pull on, you're going to get the same reading on both scales because action and reaction forces are balanced. So I'm going to hook my 2. First of all, you want to make sure they are calibrated. So let me double check that they're calibrated accurately. There we go. That's 0 newtons. And that one's reading 0 newtons. So I'm going to hook these together and pull on either one. And you may not be able to see the numbers, so I will read them to you. But I'm going to pull on the right one first. This one over here. I'm going to pull on that. And when I pull on the right one, I got this at 3 newtons. The one on the left is at 3 newtons. And the one at the right is on 3 newtons. Okay. So now what if I pull on the left one? I'm going to pull on the left one, this one over here. Pull it down to 3 newtons, and this one also here on the right is also at 3 newtons. So it doesn't matter which I pull on, they read the same. Again, this verifies Newton's third law of motion, because if I identify action-reaction forces, I'll use left and right. If I pull on the left one, that's the action force. The reaction force, the one on the right, is identical or exactly the same. So action-reaction forces always are equal and opposite. Newton's third law of motion. And then finally, come up with some, I want you to state some action-reaction forces. I'll help you with the first one. You push down on your desk. That's the action force. Now you state the desk. The desk pushes back on you. Okay, you got to state action, reaction force. And you can practice with these other ones down here. Okay?